So, let's talk about one of science fiction's absolute biggest dreams, which it turns out is also one of physics's biggest nightmares: faster-than-light travel. We're going to dig into the really deep and honestly kind of reality-breaking reason why the universe has this one single rule that it just will not let us break.
Okay, let's just jump right into the deep end. Because this quote, this is everything. This is the whole puzzle right here. And I want to be super clear, this is not a metaphor. This isn't some poetic way to say something is really, really fast. According to the actual laws of physics, this is a literal, unavoidable side effect of traveling faster than light. And it's our first big clue about why it's a no-go.
You know what, throughout human history, we've always been a species that breaks barriers. We see a limit, and our first instinct is to poke it, and then figure out a way to get past it. So it just feels natural to look at faster-than-light travel as the next big thing on the list. It almost feels inevitable, right?
I mean, you can see the pattern so clearly when you look back. For the longest time, we thought the sound barrier was like a physical wall in the sky. It wasn't. We thought escaping Earth's gravity was basically impossible. Nope. Every single time a big leap in our tech made the impossible, well, possible. So you gotta ask, why should the speed of light be any different?
This is the question that makes perfect sense, doesn't it? It just feels like an engineering problem. You'd think if we just had more power, a better rocket, we could smash this barrier just like all the others. But the problem isn't what's in our engines, it's what's written into the fundamental rulebook of the universe itself.
To really get our heads around this, we have to start with the first hurdle, which is probably the one you've heard about, the super weird effects of Albert Einstein's special relativity. And this is where our everyday common sense reality just starts to completely fall apart.
This is the absolute core of it. Space and time, they're not separate things. They're actually woven together into this one fabric called space-time. And a key rule of space-time is this: the faster you zip through space, the slower you move through time, compared to someone who's just standing still. And this isn't some wacky theory. It's a proven fact. The clocks on our GPS satellites, because they're moving so fast, literally tick slower than the clocks down here on Earth. We actually have to constantly correct for it, or GPS just wouldn't work.
So let's say you're in your spaceship and you start approaching the speed of light. Three really bizarre things begin to happen. We already talked about your clock slowing down, but on top of that, your ship would actually physically get shorter in the direction you're traveling. And, this is the big one, the amount of energy you need to go even a little bit faster starts to climb, exponentially.
So how much energy would it take for anything with mass, you, me, a spaceship, to actually hit the speed of light? Well, the answer is infinite, an infinite amount of energy. So right there, from a practical standpoint, it's game over. It's impossible. But that's not even the real showstopper. Because here's the truly wild part. Even if you had a magic box with infinite energy, the universe still wouldn't let you do it. The infinite energy problem, when you get down to it, is an engineering problem, right? The real issue is so much stranger. It's a fundamental logic problem. It's something that threatens to break reality itself.
Okay, so let's play pretend. Let's say we find a cheat code, a wormhole, a warp drive, some kind of sci-fi magic that lets us get around that whole infinite energy thing. What happens then? Well, then we smash headfirst into the real barrier, the one that has nothing to do with technology and everything to do with plain old logic.
And that barrier has a name: causality. It is the most basic, fundamental rule of our universe. You drop a glass, then it shatters. You send a text, then it's received. Cause always comes before effect. Always. Without that simple rule, the universe just becomes complete nonsense.
Now this is the mind-bending part. Einstein's relativity showed that two people moving at different speeds can actually disagree on when events happen. That's weird enough. But the one thing they will always agree on is the order of cause and effect. Unless something breaks that light barrier. The second you send information faster than light, you guarantee that for some observer somewhere out there, the effect will be seen before the cause. The message will literally arrive before it was ever sent.
Okay, I know this can feel a little abstract, so let's make it really concrete. Let's use a simple thought experiment that perfectly shows the paradox at the very heart of all of this.
All right, just walk through this with me. Step 1, you invent your amazing FTL machine. Step 2, you use it to send a message back in time to yourself yesterday. The message is simple: don't build this thing. Step 3, yesterday you gets the message and, being a smart person, decides to scrap the whole project. The machine is never built. But wait a second, if the machine was never built, how did you send the message? It just creates this impossible loop that cancels itself out. It's a total breakdown of logic.
And that little paradox, that's not just a fun brain teaser. That reveals the true reason the universe has this speed limit. It's not a barrier for us to break. It's a fundamental rule that stops reality from crashing.
And this really shows you the difference, doesn't it? The energy problem is an engineering challenge. It's a how-to problem, even if it is an impossible one. But the causality problem, that's a what-is problem. It's not that we can't figure out how to build the machine. It's that the very logic of the universe says a machine like that cannot exist without creating a contradiction that unravels everything.
So the speed of light isn't a limitation. It's a feature. It's this cosmic law that acts like a guardrail, and it's protecting the very things that allow the universe to even exist in a way we can understand. Cause and effect, logical order, and a reality that, makes sense.
And that is the ultimate takeaway here. The universe isn't trying to stop us from exploring the stars. It's protecting itself from the absolute chaos that comes from a paradoxical, nonsensical existence. The speed of light isn't a finish line we're meant to cross. It's the fundamental rule that keeps the entire game of reality playable.
So, we've seen how going too fast breaks time itself. But what about another one of those absolute limits? The limit of cold. What happens when you try to break the laws of temperature? We'll get into that in our next explainer, where we're going to ask, why is it impossible to reach absolute zero?